So, welcome back to the AI Math Club. As you can notice, now I have new updated name. It's not Machine Learning Math Club anymore. It's AI Math Club. So, a strong foundation in mathematics is essential for mastering artificial intelligence. The AI Math Club's campaign is designed exactly to depend your understanding of this, understanding of the mathematical principles that underpin AI algorithms. This initiative focuses on building an intuitive grasp of key math concepts and connecting them to real-world applications in AI and data science. But before we start, I'd like to mention that it's a friendly and inclusive space, so let's encourage each other and lift one another up. Negative comments, jokes, or behavior that put others down have no place here. Please maintain a professional and friendly attitude. If something doesn't feel right, let the host know during the event or reach out via email. We are here to make sure everyone feels comfortable and included. This event session will be recorded. So, today we are going to dive right into the basics, covering syntax, variables, and how Python handles numbers. This is the foundation you'll need to data science with Python. If you have some coding experience, that's great. If not, don't worry, we'll take it slow. Python is named after the British comedy troupe Monty Python, so we'll even have a little fun with our first program. Let's start with a quick little program. Take a look at this code. Even if you have never seen Python before, try to guess what it does. Don't worry, if you are completely lost, that's what we are here for. The output is shown on the next slide, but try to predict it first. Here's the output, and let's walk throughout the code line by line. First, we assign the value 0 to a variable called spam amount. Then we print its value. We add 4 to spam amount. The if statement checks if spam amount is greater than 0, and if it is, it prints a message. Finally, we created a vegan song by multiplying the string spam by spam amount and print it. Notice how the strings is repeated. This line demonstrates variable assignment. We are creating a container spam amount and putting the value 0 inside it. The equal is the assignment operator. A key feature of Python is dynamic typing. Unlike some other languages, we don't need to specify what type of data spam amount will hold. It can be an integer, a string, or even something else later on. Here, we are using the print function. Functions are reusable blocks of print takes whatever you put inside the parentheses, which called arguments, and displays it on the screen. We'll be using print a lot to see the result of our code. The line starts with hash symbol. This is a command. Python ignores anything else. The hash symbol is just for us humans to understand the code. The next line after comments shows reassignment. We are changing the value of spam amount by adding 4 to its current value. Now let's talk a little about conditionals and indentions. Indentions is crucial in Python. It's how Python knows which lines of code belong to the if statement. In other languages, you might see curly braces. Python uses indentation for this, making the code very, very readable. This is an if statement. It checks if spam amount is greater than 0. If it is, the code indented below it is executed. Here is our first string. Text enclosed in quotes. We can even multiply a string by a number. This repeats the string that many times. Python has some neat tricks like this. Python has different types of numbers. Spam amount is an integer, a whole number. Numbers with decimal points are called floats. The type function tells us the type of the variable. It's very, very useful for checking what kind of data you are working with. Python supports all the standard arithmetic operators. Here's the list of them. Notice the difference between slash, which is true division, and double slash, which is floor division. Floor division gives you the integer part of the quotient. And like in traditional mathematics, Python follows a specific order of operations. When evaluating expressions, this is often remembered by the acronym PEMDAS or BOMDAS. Parentheses or brackets are evaluated first. Exponents or orders come next. Multiplication and division are performed from left to right. Additions and subtractions are performed from left to right. As you can see from the example, Python follows these. For example, in -3 plus 3 multiply 2, the multiplication is performed before the addition. The example that had hate Sam and my hate Sam demonstrates why parentheses are so important. Without them, the division is performed before the addition, leading to an incorrect result. By adding parentheses, we force Python to add the height before dividing, giving us the correct height in matters. Understanding the order of operations is crucial for writing correct and predictable code. When in doubt, use parentheses to make your intention clear and prevent unexpected results. This is absolutely important in machine learning and artificial intelligence when you are creating complex mathematical formulas for your models. Functions is the building blocks for reusable code. We'll learn how to use existing functions, create our own, and importantly, how to get help with any function in Python. Functions help you organize your code and avoid repetition. But we have even help function in Python. In artificial intelligence, you'll constantly encounter new libraries and functions. Let's start with incredibly useful help function. The help function is your primary tool for navigating this landscape. It provides crucial documentation, saving your time and preventing errors. In complex AI projects, efficiently understanding library functions is essential. If you are ever sure about what a function does, just use help. Here's an example with the round function. It displays the function's documentation. So if you don't know, you can pass a name of function you like to get documentation. Functions allow you to encapsulate and reuse blocks of code. In AI, you'll define functions for tasks like data processing, model training, and evaluating. Writing clear, well-documented functions is a vital for collaborative AI development and maintaining complex models. Here's a simple example of a pre-process data function, which is a very common task in machine learning. It displays the function's documentation. In AI, modularity is key. Functions enable you to create reusable components, making your code more manageable and scalable. Imagine training a neural network. You'd have function for data loading, forward propagation, back propagation, and more. Default arguments allow you to make functions that are more flexible and allow for easier hyperparameter tuning. In this example, epoch is a default parameter. Higher order functions, where functions are passed as arguments to other functions, are common in advanced AI. This allows for extremely flexible code. For example, using the key argument max function lets you customize how the maximum value is determined. This is very useful when trying to find the best model based on a custom metric. Here, we use an anonymous lambda function to pass the custom metric into the max function. Functions that don't use the return keyword return none. However, these functions can still be very useful. This print function prints to the console, and the help function prints documentation. In AI, you will use functions that have side effects for tasks like logging progress and saving models to disk. These are very important to the AI workflow. This example shows a function that saves a model and prints a confirmation message. Booleans and conditionals, which are essential for creating intelligent systems, can make decisions based on data. These are the building blocks of AI logic. Booleans represent truth values, and comparison operators help us generate them. In AI, we use this to evaluate model performance, compare predictions, and make decisions based on data. Here's an example of checking. If a model's accuracy is above a certain threshold, combining Booleans with logical operators allows for complex conditions. Understanding the order of operations and using parentheses is crucial. This is very important in AI when you need to check multiple conditions before making a decision. For example, checking if a model has high accuracy and low loss. Conditionals allow our AI models to make decisions. The if, and else statements enable branching logic, executing different code blocks based on conditions. This is fundamental for classification, where we assign labels based on prediction values. This example shown is a simple classification function. Python can implicitly convert values to Booleans. Empty lists, strings, and zero are considered false, while others are truthy. This is useful for checking data availability and handling edge cases. This example shows checking if a list is empty. Booleans and conditionals are the backbone of decision-making in AI. They enable us to create intelligent systems that can adapt to different data and situations. They are used for data validation, error handling, and implementing complex algorithms. Hyperparameter tuning often uses conditional logic to adjust training based on performance. Lists store orders sequences of data, vital for representing features vectors, datasets, and more. Indexing allows you to access individual elements. Negative indexing is useful for retrieving elements from the end of the list, which can be helpful when dealing with time series data or when you need to access the last few elements of a list. This example shows accessing the first and last feature from a list. Slicing lets you extract portions of a list, which is crucial for tasks like splitting data into training and validation sets. Lists are mutable, meaning you can modify them in place. This is essential for data processing, feature engineering, and other AI tasks. Here's an example of splitting data and modifying a list. Python provides built-in functions and methods for working with lists. Len function gives you the size. Sorted function sorts the list, and sum function calculates the sum. Append function adds elements, and pop function removes them. These are used extensively in AI for data analysis, feature manipulation, and more. Here's an example of calculating and average and appending to a list. Tuples are similar to lists but are immutable. They are often used to represent fixed data, like for example, shape of a neural network layer or coordinates. Immutability ensures that the data remains unchanged, which is important for maintaining data integrity in AI applications. Here's an example of tuples being used for model shapes and coordinates. Lists are fundamental to AI. They are used to storing and manipulating data, representing models, and splitting data sets. Mastering lists is crucial for any AI practitioner. Lists are used in every aspect of AI, from data ingestion to model deployment. For loops allow us to process each item in a second, which is crucial for integrating over dataset, feature vectors, and batches of data. Range function is often used to generate indices for assessing elements. This example shows iterating over a list of feature vectors. This example shows a basic training loop. List comprehensions provide a compact way to create lists by applying transformations and filters. This is extremely useful for data processing, feature engineering, and creating derived features. This example converts predictions values to binary values. Adding conditional statement to list comprehensions allows for filtering elements based on specific criteria. This is essential for data cleaning and preprocessing tasks, such as removing out filters or invalid data points. Loops and limit comprehensions are fundamental to AI. They enable us to iterate over data, train models, preprocess data, and create new features. They are used in every stage of AI pipeline, from data ingestion to model deployment. Understanding and mastering these tools is crucial for building efficient and effective AI systems. Strings are essential for processing text data, such as natural language processing tasks. String methods allows us to manipulate and format text, which is valid for tasks like tokenization, streaming, and creating formatted output. This example shows basic text processing. A string formatting quiz format function is crucial for creating readable reports and displaying model performance metrics. It provides precise control over how data is represented. This example how to format accuracy and precision percentage. This example shows how to format accuracy and precision percentages. Dictionaries are used to store structured data, such as model parameters, feature mapping, and configuration settings. They provide efficient access to valuable based on keys. This example shows accessing model parameters. Iterating over dictionaries allows us to process key values pairs, which is useful for tasks like feature mapping and parameter tuning. This example shows iterating over feature names. Strings and dictionaries are fundamental to AI. Strings are used for text processing, while dictionaries are used for data representation and configuration. These tools are crucial for tasks like NLP, data processing, and model management. Imports allows us to use code written by others, extend Python's built-in capabilities. For example, NumPy and scikit-learn are essential for AI. Using aliases like NP simplifies code. Importing specific functions avoids namespace conflicts. This example shows importing numerical operations, learn for machine learning, TensorFlow, PyTorch for deep learning, and Pandas for data manipulation. These libraries provide powerful tools for building and deploying AI models. Visualizing data is crucial in AI and data science for understanding trends, patterns, and model performance. Visualization helps us gain valuable insights from data. It allows us to see patterns that might be missed in raw numbers, helps us to find anomalies that could impact our AI model, and is a strong tool for communication results to non-technical people. Matplotlib is the most widely used plotting library in Python. We'll focus on Matplotlib PyPlot, which provides a simple interface for creating various types of plots. This library is very important when exploring data and when presenting model results. Line plots are used to show trends over continuous intervals. This example demonstrates how to create a basic plot and add labels and a title. The PLT show comments is important. Without it, the graph will not display it. Scatter plots are used to show the relationship between two sets of data. They are very useful for identifying correlations and outliers. This example shows how to create a simple scatter plot. Histograms shows the distribution of a variable. They are useful for understanding the frequency of different values in a data set. The example shows how to create a basic histogram. Matplotlib provides many options for customizing. You can change colors, line styles, and markers to make your visualization more informative. Adding legends and adjusting axis limits can also improve clarity. These customization options are important when creating graphs for presentations and publications. Plotting plays a vital role in AI and data science. We use it to monitor model training, evaluate performance, explore data, and communicate findings. Visualization are essential for understanding and improving AI models. DataCamp provides interactive coding exercises that make learning Matplotlib intriguing. The tutorials and courses are very practical. They have very good tutorials that are very focused on specific skills, so you can learn very quickly. They have a good introduction to plotting with Matplotlib in Python tutorial. This link will be shared later in our Discord channel. Also, YouTube is a fantastic free resource. Channel pythonprogramming.net offers comprehensive Matplotlib tutorials. I'll share this link with you also. And I'd like, as a homework, try to write a simple Python script to calculate linear equations and plot graphs using Matplotlib. And of course, continue linear algebra on Khan Academy. So that brings us to the end of today's session. Thank you all for your participation. It was great to have you all here. If you have any questions at all, don't hesitate to reach out on our community Discord channel. This session was recorded and will be available on our YouTube channel later. So if you want to review anything we covered, or if you know someone who couldn't make it today, you can rewatch it at your convenience. I really appreciate if you could take a few minutes to fill out the post-event feedback form. Your feedback is invaluable in helping us improve and make future sessions even better. Once again, thank you for joining. See you in our next session next Sunday. Until then, keep learning, experimenting, and building with AI.